So just reviewing, everybody locking, right? People still trying to come in. Right. So speed time or speed velocity graphs, that's what we're jumping into today, right? So a speed time graph shows how the speed of an object changes over time, right? Key features, your horizontal line, which is like a flat line on your speed time graph. Horizontal is this way, right? That horizontal line means that speed is constant, no acceleration, right? Upward slope means your graph is going from bottom left to top right. That upward slope means speed is increasing, okay? It's accelerating. Steeper slope means faster acceleration. Downward slope now, that means deceleration. It's like your speed is coming to zero. You're decelerating, okay? Hold on. Right. Line touching the time axis means speed is zero. Object, it's at rest. It is not moving, right? Important calculations. The gradient of the slope or the gradient of the line is what the acceleration is, right? How do we find gradient? Gradient is equal to y2 minus y1 over x2 minus x1, where x1 and y1, well, x1 comma y1 and x2 comma y2 are coordinates on the speed time graphs for that period, right? Positive gradient means acceleration. Negative gradient means deceleration, right? So basically in physics, you can write acceleration as change in speed divided by change in time. It's the same formula we have above here, right? Area under the graph is the distance traveled. So anytime they ask you for the distance, all you need to do is work out the area under the graph and you will get your distance traveled. Speed is equal to distance over time. From this formula, we can get two other formulas, which is distance is equal to speed multiplied by time, and time is equal to distance multiplied by speed. You're ready to jump into questions? Raise your hand if you're ready. Oh, I know this is not no plating. I do not have any textbook questions here. We're jumping straight into January 2020, right? So let's analyze this speed time graph, right? You'll stay with me, So the speed time graph below, not drawn to scale. That's not drawn to scale, meaning that this is not the actual lengths and stuff, right? Shows the three stages of, three-stage journey of a car over a period of 40 seconds, right? So let's analyze something. So you see this x-axis here? That's the x, did not write in. Let me write it in. This is your x-axis. Your x-axis represents time in seconds, right? Your y-axis, this is your y-axis here. Your y-axis represents your speed in meters per second, right? So let me ask some questions, right? I'm going to question some people. Rudra, starting with you. For stage one, based on what everything I just read there, and I'm hoping you had time to go over it over the past week, right? Stage one, which means an upward slope. Is that an acceleration or a deceleration?
It's an acceleration.
Excellent. Excellent, right? We go into Empress. Empress, stage two. It's a horizontal or a flat line, right? Is that an acceleration, a deceleration, or just constant speed? Empress.
Yes, sir. Is it a deceleration?
No, deceleration is when the slope is like this, right?
Oh,
When the line is horizontal, look, it's right up here. Watch it. I want to show you where the notes are. Horizontal line, right? A flat line means speed is constant. There's no acceleration. Acceleration is zero, right? No acceleration for that stage of my graph. And for stage three, Isaiah, stage three, is it an acceleration, a deceleration, or constant speed?
Acceleration, sir.
Stage 3 is acceleration,
Deceleration, sir.
deceleration, right? So we good with all these things here now. Let me see what this question asking us, right? So they want us to determine the acceleration of the car for each of the following stages of the journey, right? Now they did not put stage 1 here, but I want to put in stage 1, right? Because I want us to work it out. Stage 1, right? Okay, so if CXC asks you for acceleration and they don't use the word deceleration, it just simply means that for that stage 3, you will get a negative acceleration. I'm going to say it again. If CXC asks you for acceleration and they don't use the word deceleration, it simply means that when I calculate the gradient of stage 3, I would get a negative number. Raise your hand if you're clear on that. I'm going to write it as a note. Right? So put this as a note somewhere, please. Note. So a negative accel means deceleration, right? So don't get tapped when you see the question asking for the acceleration, and then you wonder, wait, how come they use the word deceleration? And Mr. said, say, it's supposed to be deceleration, stage 3. It just simply means that your acceleration would be a negative number, right? Guys, I messaged in the group, right, that we will be going to Saturday from Wednesday. So given, write this down in red, given 2 coordinates on the given stage of a speed time graph, right? So we're going to call it 2 coordinates. I have this written above, but we're writing it again. So given 2 coordinates on the given stage of a speed time graph, all right, so this coordinates will be x1, comma y1, and x2, comma y2, acceleration, which is the gradient, is equal to y2 minus y1 over x2 minus x1, right? So I want someone to help me find 2 coordinates on stage 1, right? So let's go to Kimani. Kimani,
Yes,
hey, why you put on your hands? Put on your hands. I've seen a lot of hands up. Kimani, we're looking at stage 1, right, Kimani? What are 2 coordinates on stage 1, Kimani, or 2 points that I could find an x and y value on stage 1, the line stage 1? Let's see how you're thinking, Kimani.
So
If you're not sure, let's say you're not sure. Huh?
16 and 12.
Boom! That's what we talk about. Proper thing. That's this point here, right? Very good, Kimani. So we have 16 on the x-axis and 12 on the y-axis. I'm very proud of you, brother. Let me see if Crow can find our next one. Stage 1, Crow. I want a coordinate on this line, stage 1. If you're not sure there, that's why I say not sure, bro.
So 16.
No, we don't have 16 and 12. That's 1 coordinate, right? Or 1 point, right? One pair of coordinates, right? Now, I want another pair of coordinates, x value and another y value for that stage.
32
If
and
you're not
40.
32 and
40.
no, that is not in stage one. Stage one is this line. Let me highlight the line. Huh? You see this line, this is what we're focusing on here. Right? Anybody thinks then they know? Raise your hand if you think you know. Go ahead, Aiden Jutram.
So 12 and 0.
No, not 12 and 0. We're on this red line here. Anybody else? Go ahead, Rudra.
12 and 32, sir.
No, that is not stage one. Focus on the red line. Anybody else? Go ahead, Adams.
0 and 16.
0 and 16. All getting closer, isn't it? 0 and 16 is not it. Anybody else? We're on this
12 and
red
16.
line. Huh? All right, so I'm going to give it out in 2 seconds.
16 and 0.
No. Go ahead, Rudra. One more try. Last try is Rudra.
16 and 32, sir.
No. So we're focusing on the red line, right? This will be the next coordinate here. 0 on the x-axis, 0 on the y-axis. Right?
Yes.
Yeah. Those are the two coordinates. All the 16 and 32 and stuff you're calling, they are not coordinates on this red line that I have here, right? So I have my two coordinates, 0, 0, 16, 12, right? So we're going to find, wait. That's stage one. The stage two, they are first. Here, what? I changing up CSEC question, Ole. Well, don't judge me. I'm changing up the question. I put it in order. 2, 3. Right? Right. So I go to stage one first. Right. Stage one, we want the acceleration, right? So the acceleration, which is your gradient. No, I want to write in blue. Right. So your acceleration, which is my gradient, would be y2 minus y1 over x2 minus x1. What I should do is write the two coordinates first, right? So let me write the coordinates here. Right. So we have 0, 0, and we have 16, 12, right? Pay attention, eh? This here would be my x1. This here would be my y1. This here would be my x2. This here would be my y2. Everybody good there? So let's go. Go into Tyler. If it's y2 minus y1 over x2 minus x1. Tyler, what is y2?
Y2 will be 12.
Right. I'm going on to somebody else because I want to make sure people following. Priya, what is y1?
16.
No. Y1.
0.
Nathan. Somebody said it's 0, right? Very good. So I'm going to Nathan now. What is x2, Nathan?
16.
16. What is x1, Caitlin?
X1 will be 0.
Right. Now, guys, I'm trying to question some more people. So let's keep your hand close to that mic. Right. So we go in. 12 minus 0 is 12, and 16 minus 0 is 16. What is can be reduced to be, Ariana? What is my acceleration?
It will be 3/4.
3/4. 3/4. Right? So your acceleration is 3/4 meters per second squared, right? Okay? So put a -2 here. This is how we measure acceleration. Okay? So you put meters per second, and then you put the -2 power. This is acceleration. So let me put that in red. So your acceleration measure, acceleration would be meters per second. No, wait, we don't put it per when you put the -1, right? You don't put it per when you put the negative. When you put -2, you don't need to put the per, right? You just put ms -2. You'll see it up here. So if you put, I saw somebody trying to come in. Right. So acceleration is ms to the negative 2 power, and speed would be ms negative 1, right? Meters per second. Okay. Let me put the or in case y'all bounced up somewhere. Or m/s squared or m/s, right? They don't want to put the 1 because the power of 1 would be understood, right? These measures are very important for any writing acceleration and speed, right? So we go into the second stage. Let me know when you all have this written down.
Oh, I got it.
Right. Scrolling up.
Okay, so I have a question.
Go ahead. Joshua, your internet real sticking.
So
I just had a class there before you all, and like people who in Grandy, the internet giving real trouble.
yes,
Go ahead, Josh.
it did give me trouble. My question was for acceleration. The formula that I give I somewhat don't understand. I understand the working, but I don't understand how you get the numbers.
Oh, I get these two numbers here, which is 0, 0. And this one here, 16, 2.
Yeah.
16, 12, sorry. All right, so I'm scrolling up.
12. Yeah, I
So you see
understand
stage 1 here?
Yeah. The y-axis
Right.
is 12, so
Right, so
and
your
the
x-axis
x-axis is
value is
16.
always first, right? The x-axis value is always first when you're writing down a coordinated, children, right? So it will be 16, 12, right? And then here is 0, 0 as your point of origin, right? So where did I get these points from? Right, so the formula is y2 minus y1 over x2 minus x1. You will see above each coordinate here, I put x1, y1. That means your x value from your first coordinate and your y value from your first coordinate there, right? And then your x value from your second. Go ahead.
So is the point of origin always going to be 0, or does it
Yes,
be
0,
different
0.
numbers?
No, point of origin will always be 0, 0. Right?
Right, sir.
So we go to
questions.
Stage. No problem. We go to stage 2. Right. So stage 2, I'm going to draw that in a different color now. Stage 2 is here, right? Right. So I want 2 coordinates on stage 2. Zanaya, what's that one coordinate on stage 2?
It would be 24 and 32.
24 and 32. Are we seeing 24 and 32? Not sure.
I can guess.
I just I'll come back to your crew. I'm just trying to go in order how I see on the screen here now. Amory, give me a coordinate on stage 2.
32 and 40.
32 on the x-axis, yes, that's this coordinate. 32, 40 on the y.
Or 12.
12. So that's one coordinate there. What's another coordinate, Aiden Ramjan?
16 and 32.
16 on the x, yes, it would be 16 on the x, right? And what on the y?
12.
12 on the y, that same coordinate is in stage 2 also, right? So we have 2 coordinates on stage 2. Guys, when we state in a coordinate, you cannot give me an x value and then another x value. It will be an x value and a y value, right? So I'm going to write these two coordinates in green for stage 2. So we have the coordinates 16, 12, and then we have, what it was, 32, 12. So above here, I'm going to write x1, y1. Above here, I'm going to write x2, y2. Okay? The formula for acceleration is y2 minus y1 is the gradient of the line. X2 minus x1. Okay, stay with me. So, all right, let me see who following here. Let's go to Nathaniel. Nathaniel Ford, what is y2?
Y2 is 12, sir.
Pick up yourself. Who's next? That's I got a glitch there, boy. Right. Mitchell. Veron, what is y1?
12.
12, excellent. Emma, what is x2?
32.
Excellent. Isaiah, what is x1?
12, sir.
X1.
30. 16, sir.
Come on, bro. Come on. Lock in. Right? So, watch it now, right? What would this work out to be, JL Singh? 12 minus 12.
12 minus 12 is 0, and 32 minus 16 is 16.
Right. And 0 over 16 would be what? 0 divided by 16 would be?
16.
0?
0.
So it's 0 meters per second to the negative 2 power, right? That's the acceleration. Remember, I told you all when your line is flat, your acceleration is 0, right? No acceleration. It's constant speed. You all know what constant speed is? When you're driving a vehicle, right? And you're going at 1 speed, meaning you ain't mashing too fast. Go ahead, Ariana. Go ahead. You're not mashing gas. You just have your gas at one speed, and you're going, so you're going, that's constant speed, no acceleration. Acceleration, now you're going, like you're going faster, right? Deceleration is like when you reach a traffic light and your mashing brakes and the car started decelerate. So you go, right? Acceleration, constant speed, deceleration. Everybody good there? Clear understanding? Raise your hand if you're good there. Proper thing, right?
Sir, may I be excused, please?
Sure, no problem. Stage 3. All right, that's all. I'm going to pull along this. I don't know why this ends it. All right. Right, let's go. Stage 3. So I'm going up to get 2 coordinates on stage 3 now, right? So I join stage 3 in a different color. All right, there we go. Right, stage 3. Where I reach by Michael. Give me 1 coordinate on stage 3, and somebody will give me the next one.
32, sir.
32? 32? I want that coordinator, so it'll be 32 comma something.
Oh, 32, 12.
32 comma 12. Excellent. Same coordinate here, right? The same coordinate. Let's go. I want one more hill.
Sir, I have a question.
Huh?
I have a question, sir.
Go ahead.
Isn't stage 3 is 40 and 12?
40 and 12, no. 40 not lining up with 12. 32 and 12 is lining up.
Oh.
Right? So, Hill, give me the last coordinate there.
Sir, I'm not sure because I was going to say that, what she said.
40, all you want to say 40, comma 12. 40 here, right? If I put a dot here, because that's the only coordinate I could get on this line here, it has no coordinate nowhere else. So if I here now, right? If it's 40 on the X hill, what would be what is it line up with on the y-axis?
12?
12? This point here.
No, sir.
12, guys? I hear somebody
32.
say,
Sir, 0.
thank you, 0. Right? 40 lines up with 0. Look at 0 on the y-axis here. That's what this point is. Right? Your understanding of coordinates have to be stellar for this. It is 40 on the x-axis because we literally on the x-axis. 40 on the x and it lines up with 0 on the y. So those two purples there would be my two coordinates for stage 3. Scrolling down. I'm going to write out my two coordinates now. So we have, well, it was 32, 12 and 40, 0. I'm going to put a little x1 here, a little y1 here, a little x2 here, a little y2 here. So your acceleration, which is your gradient, would be equal to y2 minus y1 over x2 minus x1. Right, so I go into my peeps now. Dominic, my sister, you there?
Yes, sir.
All right, hold on. Let's go down with this here. Hold on. Right, so Dominic, I come in here now. What is y2? You have it written now?
Yes, sir.
Right, what is y2?
Y2 is 0.
All right, that's all I'm asking somebody. What is y1? Janaya, St. John, what is y1?
Y1 is 12.
Excellent. Amelia, x2. Amelia, x2. 40. Orion, x1.
32.
Right. So I just want to make sure everybody following now. Because if somebody jump out here and tell me, "Sir, me understand now," I will know you're playing the fool home. Right? For somebody to jump out and tell me they didn't understand this, they playing the fool home. Right? So 0 minus 2, 12, sorry, would be negative 12 over 40 minus 32 would be 8. So this can be reduced to be, hold on, right. So this can be reduced to be what?
3/4.
Yeah, 3. No, it'll be 3 into 12 is 4, not 3. 4 into 12 is 3, and 4 into 8 is 2.
2.
So it'll be negative 3 over 2. Right? Negative 3 over 2. And this will be meters per second to the negative 2 power, which is your acceleration. Now, how this is negative here? Would this be a positive or a negative would this be an acceleration or a deceleration?
Deceleration. Deceleration.
Deceleration. Excellent. All you're real following today, boy. I'm super proud of that. Super proud of that, right? So, right, when you get a speed time graph question, right, analyze the information given, right? There we go. They said Monty is cycling at 12 meters per second, right? After 4.5 seconds, he starts to decelerate. And after a further 2.5 seconds, he stops. The speed time graph shows the information below. So I'm going to ask some questions. Who was the last person I talked to? Was Oran. So Sadie, I'm not sure if I'm seeing the graph properly. So let me put it in red. Hold on. The graph is actually start here. It came to this point here. Then it came down. Right? Well, obviously you're seeing this part clearly. But I just want to make sure you're seeing this part up here, right? This is the first part of the graph, right?
So we don't want to see the graph work.
No. We don't draw no graphs yet unless they ask us to draw it, right?
Okay, sir.
Okay? Like how that. Right, that's our John Magnus line. This is the first part. Right. So it stop here and then it started to go down, right? Right. That's the graph. So Sadie Edwards, for the part of the speed time graph that is flat like this, what the acceleration would be?
Constant acceleration. Well,
Real paying attention to the like I waiting for somebody to give me a wrong answer to both them and like I ain't getting no wrong answer. Right? Very good. Okay, so your acceleration is 0 when the line is flat like this, right? And when the line is sloping downwards, Melisha, will it be an acceleration or a deceleration when it is sloping downwards?
Deceleration.
Excellent. It's a deceleration. So these are the things we could analyze here before we even jump into the question, right? We know for that part of the graph, it's a constant acceleration, right? Then when it's going down this way, it's a deceleration. Okay? So there we go. Look what they actually here. Calculate the constant. Why they use the word constant deceleration? Right? They wanted to calculate the deceleration, right? So it's like you have two stages for your graph. They did not write it in here. But for this question, you have stage 1 and then you have stage 2. So let's go to Tristan. We're looking at stage 2 because they want us to find the deceleration, right? Okay?
Yes.
Tristan, stage 2. I put in the stage 1 and stage 2, right? For stage 2, give me 2 coordinates on that sloping line there.
12 to 7.
12 on the x. What value is always first, Tristan, when you're listing a coordinate? When you write in a coordinate, which value is always first? X or y axis?
X.
Right, your x-axis value is always first, followed by a y-axis value, right?
Yes.
So we go back again to stage 2. Give me a coordinate on that line. Coordinate of a point on that line.
Okay, well.
As zooming in, eh?
Oh.
That's all. Yeah, that's the x and y axis, right? The coordinates of a point on stage 2.
Stage 2, okay. Well, I know stage 2 is starting in between 4 and 5 there.
Excellent, excellent. So that'll be 4.5 on your x-axis, right?
Yeah.
And the y-axis value now for this point.
7.
Say, you sure? I want the y-axis value for this point here, where stage 2 starts. Look how big I put the dot here. What's the y-axis value for that point?
Oh, well, the axis would be...
This is your y-axis, right? And this is your x-axis. What number does that point line up with on your y-axis? If you was to look at the point and go to your left, what number does it line up with? Look at the point, go to your left. What number it lines up with?
Well, as you pointed out here, 7 is the x-axis.
No, bro. We on this. You see this here? Right? Look how much arrows are going to point it. You see this here? This is the coordinate you're looking at. Right?
Okay.
So you tell me the x-axis value. I'm going to use a different color. Right? You tell me the x-axis value is between 4 and 5, right? So you tell me the x-axis value is here, between 4 and 5, right? What is the y-axis value for that point now, Tristan? Come on, man.
Oh, the y-axis would be 5.
All right, so I'll go with what you say. You're telling me 5. Look, your y-axis, 5 on your y-axis. So this is 3. 1 to 3. So going on here, but this will be 1.5. Right? This will be 3, 4, 5. So this will be 4.5. So 5 is in between here. So you telling me that coordinate up there line up with 5 here?
No.
What number on this y-axis is it line up with, Tristan? Come on, man.
Okay.
Help him, Abijah. Abijah Alexander.
Sir, can I try?
So
Yes, sir. I'm trying to go in order on the screen. Abijah.
the number line up with
On the y-axis.
Answer is
Ariana, help them.
4.5 on your x-axis and then 12 on your y.
Thank you.
Yes, it is 12.
So I want again, Tristan, I want to get your brain now. Why were you not able to see that? Okay, so Tristan, you see what I'm doing here? You see this what I'm doing here? Watching my screen. You see how I have my hand here?
Yes.
So you're basically watching what this line. So the point is where my two fingers are touching here, right? You see that?
Mm-hmm.
And you're basically watching what number it lining up with on the x-axis. And then you have to watch what number it lines up with on the y-axis. So I want to know, how were you not able to see that that number is 12 up here?
I guess I wasn't really focusing on it properly.
All right, but you understand it now?
Yes.
Abijah, you were not able to see it too. Abijah,
yes, sir.
why your camera off? Abijah,
Yeah.
why is your camera off? Put on your camera, please.
So
Right, so there we go. 4.5, comma 12 is this coordinate. Give my next coordinate on that stage 2, Isaiah.
So, yeah.
Sir,
Yeah.
you don't mind if I eat while
Yeah, you
in
can.
class? No, like if
Yeah.
I could turn on my camera because so so
Yeah, go ahead.
So
You can go ahead, right? Yeah. Isaiah,
Yes, sir. 7 and 12.
7 on the X. So I'm watching, if you're watching this point here, down here, right?
Yes,
You said
sir.
7 on the X. So this line up with 12. This point line up with 12 on the X axis.
No, sir, sorry.
What number is that lining up with there? I mean on the Y axis. 7 on the X and what number on the Y?
9, sir.
But like I watching this graph wrong, man.
Isaiah, it's a 0 there.
This number here is 9, bro.
No. It's a 0, Isaiah.
It's 0.
0 at the end.
Guys, I want to go through this again. You see this point here? Look how much arrows are putting on this point, right? Okay? This arrow, this point here, we need the x-axis value, which is 7. And then the y-axis value would be this number across here. Right? That's this number down here. That is what that is lining up with. You hear me, Mr. Isaiah? That number is not 9.
Yes, sir. That was my bad. I was trying to trace it from on top.
How we can trace it on top if we underneath here, bro? We down here, right? Don't worry, you have plenty questions. This is all we're doing today. We only doing speed time graphs today.
Yes, sir.
All right? So all you have to get this before we done here. Have to get it. Right, so let me erase this, right? So we have the two coordinates. I'm going to write it down here, right? Our coordinates are 4.5, comma 7. No, 4.5, comma 12. 4.5, comma 12. Right? And then 7, comma 0. So I'm going to write in now what my formula for, well, if they say deceleration, you just know that the acceleration gonna be 0. So I could simply put acceleration, which is a gradient, right, is equal to y2 minus y1 over x2 minus x1. So I'm not going to put any y1 and x1 above for this one, right? Find a little pen, boy. I'm taking a pen. Hold on, Maybe it's just write it over. All right. All right. This will be y2 minus y1 over x2 minus x1. So who's next on my screen, Melika? What is y2 here, Melika? I'm not putting it on a baby no. What is y2? Excellent. Adams, what is y1?
Y1 is 12.
Excellent. Aaron, what is x2?
X2 is
7.
We wanted Aaron to work. X2 is 7, right? Somebody done said, what's x1, Aaron?
7.
X2 is 7. What's x1, Aaron?
So repeat that, x1?
Yeah, x1.
4.5.
Excellent. Right? Lucky, Aaron. This is not a play thing, I was fed up till all of that, I just see men smiling and thing in this class. This is not a smiling area, Well, they go smile when class done. So 7 minus 4.5 will be what, by 2.5? Now, I want somebody to go on their calculator and do negative 12 divided by 2.5 and give me what the answer is there. Negative 12 divided by 2.5. Anybody? Whoever get the answer first there.
Sorry,
Negative
48.
4.8.
4.8.
Negative
And this will
4.8.
be meters per second to the negative 2, right? That's my measure for acceleration. Or, right, you could just put meters per second squared, right? Anyhow you want to write it. Sure, Amory. So this here, because it is negative, it is a. Because it is negative, it is a. Come on.
Deceleration.
Thank you. Let's go. Everybody have this? Right. So speed. Speed is equal to what? I had it written above. Speed is equal to what, Rudra?
Speed is equal to distance over time.
Excellent. That's the kind of pace I'm looking for. Distance over time, right? Now they did speed is equal to distance over time, right? They did give us our time. What's our time here, Empress? Empress. What's my time?
So the time is 7 seconds.
Right, 7 seconds, right? We need to find the distance. We don't know the distance. Okay? But I gave you all a note above. Crow, how do I find the distance from a speed time graph? Crow. Distance.
Yes, sir.
How do I find the distance from a speed time graph? Tyler, distance from a speed time graph. How do I find the distance?
By time?
Huh?
Speed multiplied by time?
Speed multiplied by 10?
No, sir, time.
He said time, sir.
Speed multiplied by time, right? Okay, no problem. Speed multiplied by time, all right. But we do have the speed now. We're trying to find the speed. I have a next note on that above. Priya, what's the note I have on distance? The distance is what?
Sir, repeat.
Is? Pause this. Right, so distance is the area under the graph.
Because the distance traveled.
Yeah, that's the distance traveled. It's the area under the graph. So I'm scrolling back up. The graph they're talking about is my speed time graph. Is this shape here. So look, I'm going to complete the shape, right? So we just have the graph there. The area under the graph is this whole bad boy here. Boom. Bang. Right? That whole bad boy there, that whole shape is going to be the distance under my graph, right? So who are going to next, boy? Aidan Ramjan. What shape this is, bro?
A right angle trapezium.
A right angle trapezium. Did I say a trapezium, right? Yeah. Right? But he is correct, you know. It have a right angle here, right? So this is a trapezium, right? So a trapezium has two parallel lines or a pair of parallel lines, which we're going to call A and B, and it also has your height. Your height is your perpendicular height or the perpendicular distance between the two parallel lines, right? So let's indicate what A is. How much seconds is A, or what's the length of A? It will be in seconds, but let's put the length, right? Who's next, boy? Mitchell. How long is common A, Mitchell? You're looking at the x-axis to determine that length, eh? For common A, Mitchell. Mitchell, if all if all in a show, let's say in a show, like we don't waste too much time.
Sancho.
Emma, what's the length of common A?
Is it from 12 to 4.5?
Right. So if we're watching the x-axis, sister, watch the x-axis. What does the x-axis start at?
Or it would be 0 to 4.5.
Excellent. So it'll just be 4.5, right? That is 4.5. Excellent. JL Singh, we're looking at B now. What is the length of B? From 0 to what? JL?
0 to 7.
Right, so this will be 7, right? We're looking at the height now. So, Mikhail, what is the height?
So the height is 12.
12, excellent. Right, so we're working in this class. Yeah, I hope all are paying attention now. Aaron, Aaron. Aaron, you're paying attention?
Yes, sir.
All right, brother. All right. There we go. So I need the formula for area of a trapezium, right? Area of a trapezium is equal to half of A plus B multiplied by height. Okay? That's the area of my trapezium. So that's what I'm going to find now. It's going to be a half of, what did we say A was again? Anybody? What A was? Come on, A.
4.5.
4.5.
Plus, what is B?
7.
Proper thing. Plus 7. Multiply by what was the height?
12.
Somebody look up down our calculator there.
Say 69.
69 flat?
Yeah.
69. Now this is your distance. So we measure in meters per second, right? Meters per second was the measure here. Look at here. From up here you'll see it, right? Meters per second, right? So it's going to be 69 meters, right? It's 69 meters because my distance is in meters. Everybody good here? So let me rock to speed now, right? We're going back to speed, okay? So we have our distance. Not somebody, I'm going in order. Hill, give me back well, speed and average speed is the same thing, right? Average speed. So your average speed is the speed over the whole graph, right? Meaning the constant area and the deceleration. So this is your average speed. Remember what the formula is, Hill? I need them formulas.
Distance over time.
Distance over time. Big up yourself, sister. Distance over time. Dominique, remember what distance is?
Distance is the area under the graph.
Right? And what did we calculate that area under the graph to be?
69 meters.
Now, this is actually 69 meters square, if you're really looking at area, but it's really the distance you're trying to find, so that's 69 meters, right? So this is your distance. I'm already with distance. Distance is equal to that. So it is 69 divided by, remind me of my time, Janaya St. John.
7 seconds.
7 seconds. So my speed will be what, Amelia? Amelia, what's my speed?
Sir, can you find my calculator?
Tristan, what's my speed?
So 9.8.
Thanks, Tristan.
Sorry, sir.
That's okay, bro. That's okay. That's okay. So, hey, what's the measure here? What's the measure? Tristan, give me the measure. 9.8 what?
Well, that would go to 10 meters.
It's average speed. So the meters per second. So you're writing it like this. Meters per second, -1, or you put in meters per second. Anyone you want to put, right? And you're not approximating.
Point is 8.5.
8.5. What after the 5?
9.85, and then there's a whole bunch of numbers afterwards.
What right after the 5?
35 is 7.
Well, then it's 9.86.
Okay.
Right? Approximated 2 decimal places. 9.86 meters per second.
Excuse me, sir.
Go ahead.
If I put 9.8.
Right. Nobody stated if they're writing, right? So the average speed for the entire duration of our journey is 9.86 meters per second, right? Going to June 2017. Put June 2017 for me in your book. June 2017. This is question 9, so let's do that, by the way. So let's have a little pat on the back. This is question 9. Okay? Well, don't jump out with CXC questions here already. Right. So don't let the word velocity throw you off. They say the velocity time graph, which is the speed time graph, right? Below shows the motion of a cyclist over a period of 40 seconds, right? So the velocity, the speed/velocity column would be the y-axis. So this here is your y-axis, okay? And down here will be your x-axis, right? So let's go down and put the graph in red, just in case anybody's not seen it. Your graph will be from here to here, which is our what? From here to here is our what?
It is an acceleration.
Very good. Very good. And then it going from here. So I put in a little dot. So it going from here, right, to B. Which is what?
Constant
speed, right? Constant speed. So let me see what Mr. CXC asking us for. 40 seconds is the journey. Calculate the gradient of, now CXC comes straight up and asks you for the gradient. So if CXC asking you for the gradient, what are they asking us for, Ariana? If they asking us for the gradient, what represents the gradient from a speed time graph?
The slope of the line is up or down.
Right, but when they ask you for gradient, I keep writing this
acceleration
word
or deceleration.
Very good, very good. Because I keep writing acceleration and then I keep putting in the brackets gradient. Because I know CXC like to play mad and they don't ask you for the acceleration, they will ask you for the gradient. But you are the knows acceleration they ask you for. Right? Going back down. So they basically ask you for the acceleration for the first stage, which is O. O meaning the origin. I'm gonna put on, hey, write as a note, because people see this O here and get through off. O means somebody mic on. Origin. O means origin, right? Okay, origin is 0, 0. So don't get tapped with that. Anytime you see that word O or 0, right? It is O, right? O to A it means it's starting at the origin, right? Now, we're looking for the gradient of that stage 1 there. Who can give me, not who? Let me see if I can get back. Actually, I started to run a little more of the classes. I don't need to question everybody now. Everybody have a fair idea, right? So I just calling on random people, right? So Nathaniel, give me the first coordinate on our first stage, which is from O, which is the origin, to A. Nathaniel.
0 and
0,
10.
0, right?
0, 0. No, sorry, 0, 0.
0, 0. That's how to mark somebody else. Joshua, give my next coordinate on that first stage there.
So may I try?
That's how Joshua go on. Joshua, Mikey, stick.
25 and 10. 25 and 10.
25 and 10. Excellent, Joshua. 25 and 10. Proper thing, right? So, hey, all I can say about these things, work on that for me now. Work on my gradient here, 0, 0 and 25, 10. Let me just indicate the second stage, which is AB, right? Give me 2 coordinates on AB. Well, we actually already have one, which is 25, 10, right? Give me the next coordinate here, A. Marie. What's the next coordinate for the period AB?
10 and 40.
Who teach you to put the y-axis value first? Was that Sarah teach you that?
No, sorry, sis.
Oh, so what's the order?
40 and 10.
Thank you, sister. Right? 40 and 10. So I'm coming down here. Let me see if I can bring it back up. Right. So for this here, it would be 25, 10 and 40, 10. Right, let's look. Find my gradients here. AKA the acceleration. For those who memory short, right? Your acceleration, which is your gradient, is equal to y2 minus y1 over x2 minus x1. I give you only 3 minutes to do that. All you need more than 3 minutes, right?
Okay, sir.
Okay, so gradient of OA is y2 minus y1 over x2 minus x1 gives you 10 over 25, which can be broken down to 2/5 or 0.4. All right, let's go. AB. Who started us? Tyler. AB.
Yes, sir. That would be 10 subtract 10.
10. Subtract 10 over
40, subtract 25.
Excellent. Which will give me what? 0 over 15?
Yes, sir. That'll be 0.
0. Proper thing. Yeah, no problem, Avery. I get a message here. Right. So that's the gradient of AB. Let me see how back and I'll go down here now. So they said complete the following statement, right? The cyclist started from rest where his velocity was. What is the speed at rest, meaning where the cyclist started here, JL6? What is the speed when he started, when he's at rest? How fast are you going when you're at rest?
He went from 0 to the point.
Not from 0. They want to know what it was. Well, 0 is the answer, but you're not going from 0 to nothing, right? At rest, meaning when you're stationary, your speed is going to be 0. Right? So the answer here would be 0 meters per second, right? And he steadily increased his velocity by how many meters per second, right? So if you steadily increase your velocity, this is actually your acceleration, right? Each second during the first 25 seconds, right? So you steadily increase his velocity by the first 25 seconds, right? So that would be the gradient. How much is his velocity going up by? It's going up by 0.4, right? 0.4 or 2/5, right? Each second during the first 25 seconds, right? During the next 15 seconds, his velocity remained constant. That is, his acceleration was what? If your velocity is constant, what is your acceleration? Anybody? Rudra?
0, sir.
0. It's going to be 0 meters per second to the -1. Now, guys, this steadily increased his velocity by this, right? Now, you see they put a velocity here, they put a speed here, they did not put an acceleration. But if you steadily increasing your speed, it's basically acceleration, eh? So that steady increase in velocity or speed is your acceleration. So that's when you're mashing gas and you're going, so your velocity or your speed is steadily increasing by 0.4 meters per second, right? Or 2/5. Going here now. Now, who gonna help me here, boy? Nathan. So you want to find the average speed. Give me the formula for average speed here, Nathan.
Distance over time.
Distance over time, right? We know what the time is, Nathan?
40 seconds.
Right, time is 40 seconds. We don't know the distance. We need to find the distance. So the distance is what, Adams? What's my distance?
For the distance, I got 275.
Right, but when I ask you what's the distance, what is the distance basically from the graph? It is what is the distance here? You know, Adams?
I'm not sure.
All right, Caitlin, what's the distance?
Sir, I don't in the script, but I have 325.
Listen to what I'm saying. Give me a definition for how do I find the distance? My distance is what on this graph?
Sir, I know you have to find the area to get the distance.
Thank you. That's what I'm looking for. Thank you very much, Joshua. That the distance is the area under the graph, which is in the shape of a what here, Ariana? What shape is this here?
It's a trapezium.
Trapezium. We have a pair of parallel lines. Boom, bang. We have our perpendicular height, which will be here. So this will be common A, this will be common B, and this will be common H here, right? So let me get some lengths here now. Common A will be equal to what, Janaya? What is common A? From this point here, which is capital A to B, what's that length there? Janaya?
Me?
Yeah? It have an next Janaya in this class?
Let's have another one.
Janaya. Who's the next Janaya? I'll call St. John next time. So yeah, Janaya St. John, because remind us dealing with who have their camera on. I don't even see any people who don't have their camera on. Right, so go ahead, Janaya St. John. What is A?
25.
Right, so it will be 25, Janaya says. So watch it. From here to here is what Janaya. What's this length here?
5.
5. Go ahead.
10.
Go ahead.
15.
So where did we get 25 from, sister?
I was watching. Yeah.
All right, cool. No problem. So we go into the next one, B, Melika. What's the length of B? Melika, not hearing you. What is B? Common B.
540.
I'm not sure what she said.
I think it was 40. I don't know.
40. I think she said 40. It sounds like 40. Right? So 40 is correct. Right? So we have A, common A as 15, common B as 40. What is my height here, Aaron? Adri. What's my height?
10.
10. Boom. Right? So this question is now food because we have everything, right? So scrolling down, I'm going to put my formula for area of a trapezium. It's going to be half by A plus B multiplied by H, which is my height. So we're going to plug in here and we're going to get a half by, somebody remind me what A is? What is
15.
A? 15. I just remember these things. I just be trying to make sure they're involved, right? B. What is B?
40.
40. Multiplied by what is height?
10.
10.
10. So what did you all get my distance to be? This is my distance, right?
275 meters.
275 meters. Somebody second this.
Yes, sir.
Yes, sir.
Yes, sir.
Right? So therefore, I can put 3 dots on 1, 2, 3. Therefore, average speed is going to be equal to distance, which is 275 over time, which is, what was time again? 40?
Yes, sir.
40 seconds.
Right. So what's my average speed here, my children?
6.88 meters per second.
Right. This is the 2 decimal places, right? That's meters per second.
Yes, sir.
Congratulations, guys, if you got this, right? Super proud of you all. Raise your hand if you get this. Let me see how much all you get this. Camera on, raise all your hand too, eh?
Sir, I was looking for the question in my notebook and I couldn't see it.
Right. The speed time graph below shows information on the first 60 seconds of a car's journey, right? So the car moved from rest here, meaning that the speed was 0 to this point here, which is stage A, and then it moves from this point here to the ending of stage B, right? No problem, Janelle. So calculate the acceleration. Everybody here knows that your acceleration is the gradient of the line for that stage, right? So your acceleration, acceleration, which is your gradient. Somebody mic on, please mute it. Right, so we deal with stage B. So the gradient at stage B would be y2 minus y1 over x2 minus x1. Right, I put in the 2 coordinates here. Give me one coordinate, hill. One coordinate hill.
40,
Well, the coordinates of 1 point would be 40, comma
15.
15, right? Well, yeah, right, we had that. And Melisha, give me our next coordinate.
60, 40.
Excellent. So we have our 2 coordinates on this line, right? Now, I'm not going to write no x1, y1 above. So let's go to Isaiah. What's y2?
15, sir.
15 is y2?
40, sir.
40 minus y1, Tyler.
Subtract 15.
X2, Aiden Jutram.
So X2 will be 6, sir.
X1, Kimani.
40, sir.
40. All right, so Priya, where you get to when you work on the top and you work on the bottom? Priya.
25 over 20.
Excellent. 25 over 20. And when we break this down, what would we get here? This will be what? Give me that as a decimal. Anybody?
1.25.
1.25? 25 over 20. I put 25 over 40.
Yes, sir.
Yes, sir. 1.25.
Right, so it's 1.25, and its acceleration should be meters per second squared. Right, that's my acceleration for stage B. Right, this is stage B acceleration. Right, calculate the average speed of the car during stage B. So you're going to work with stage B. Average speed is equal to distance over time. I can start to write abbreviations now, right? Because everybody's supposed to have a fair understanding of what's going on here now, right? So speed is equal to distance over time. I know the time, right? Actually, we need to be able to assess the time here. So for stage B, how long is stage B here, Aiden Ramjan? Stage B, Aiden.
Yes, sir. How long it is?
Yeah.
Oh, sorry, sir. It is 40. No, that's height. Long is 20. 20, sir.
20. Excellent. Very good, Aiden Ramjan. Very good. You're on top of things, right? Because the time from here to here would be 40 seconds. What is it? 20 seconds. Right, 20 seconds. So you know time is equal to 20. We need to find our distance, right? Your distance would be the area under the graph. But my brothers and sisters, my children, we are not looking at the entire graph. We are only focusing on stage B, right? So let's look at stage B. What is the shape stage B is in, Nathaniel? Stage B is a what?
Stage B is a trapezium.
Excellent. So this is one parallel line. This is our next parallel line here. This is your common A. This is your common B. Here would be my perpendicular height, right? This is your height. So let me go B. What is B, Rudra?
So I worked it out as distance is speed by time because that's the formula you gave us.
Yeah,
before.
No, you see, the thing is, distance is the area under the graph, right? Now, if you're trying to find, remember, so the whole stage B, if you want to do distance as speed multiplied by time, remember along here, what's something here, right, Rudra? At this point here, right, your speed is actually 15, okay? Look,
Yes.
at this point here, your speed is something else. That's what? That's 21. Your speed is here. At this point, quite up here, your speed is 40 meters per second. So we're looking for your average speed. Okay?
Yes, sir.
Okay, your average speed would not just be, your distance would not be your speed multiplied by your time. You're looking for your average speed. So in order to get your distance, we calculate the area underneath the graph, and then we divide it by the time, right?
Okay, sir. Noted.
So know what B is?
B would be.
Yes, sir. Yeah, what is B?
B would be 40.
Excellent. 40, right? Excellent. Sadie, what is A?
Sir, I only worked out stage B. I didn't quite understand stage A.
We're not dealing with stage A. I talking about common A.
What?
Remember, we're trying to get our lengths to calculate our area of the trapezium. So we have common B and common A. What is common A here?
Common A would be 40.
No, 40 was common B. That's this big length here. What is common A? The other parallel line will be called common A.
So I got it, so.
Yeah, go ahead, help
Well, can I say it too? 15. 15, sir.
You see that here, Sadie? Is the distance from here to here? It's 15, right? Sadie?
Okay.
Right? What is my height here? Caitlin, what is my height? What is H?
Sir, I didn't finish the question.
Caitlin, look, you see it here. What's the height, Caitlin?
60.
60. So from here to here, 60. Watch it. We only focus on stage B, eh? Caitlin, from here to here, 60. What's the distance from here to here, Caitlin?
Oh, my bad. 20.
20. Thank you. So we have everybody here, right? We're going to plug these things into our formula for area of a trapezium, right? So area of a trapezium is a half by A plus B, right? Common A. Come on, remember what common A is?
15.
15.
Yeah, height is 40. No, not 40. 20.
40. B, common B is 40, and your height is
20.
Right. So what's my final answer here? What is the distance? The area of the trapezium is the distance. I find all this sticking like if all it didn't calculate it, boy. What y'all get here?
550.
550. Somebody second that.
Yes, sir. It's 550.
Right. So this
Yes,
will be
sir.
550 meters because this is the distance we calculated here. So we're going to roll into our speed. The average speed will be equal to a distance. Ooh, I put 555, yes? 550 divided by my time, which was 20. Okay? Remember, that's the time for stage B. And what would my average speed be, my children?
27.5.
27.5 meters per second. I could write it like this, or I could write it meters, or I could write it meters per second with a -1, right? However you want to write it. Everybody good here? Those who have to write. We will get... Guys, I just had to run back through this one and I now realize it was not tapering. Enough from where it wasn't tapered. I think we had this. Is this one I didn't tape. So let's run back to this, right? Average speed is equal to distance over time. Your time is 20 seconds because it's stage B alone we're focusing on, which is between 40 and 60, which is 20. We have the length of this side here, which is A. We have the length of this side here, which is B. Here's 15, here's 40. We plug it into our formula. We get our distance to be 550 meters. So speed is equal to 550 over 20, which would give me 27.5 meters per second, right? That is my speed. So we go back down here. So they told you your acceleration is 2.5 meters per second squared, which will, your deceleration is that, which will be negative 2.5 meters per second squared, right? So I have two coordinates for that new stage, which is going to be a deceleration. We started at 60, 40, and we coming down, right? So I have 60, 40. We don't know where x2 will be. So what we know is that when you come to the x-axis, the value of y will be 0. That's what we know. And this is equal to negative 2.5, right? So I can't take this entire thing now, carry it to the right, and I will be multiplying, right? So watch it. So this will be 0 minus 40 would give you negative 40 is equal to negative 2.5 multiplied by x2 minus 60. This is algebra now, eh? You're going to take this now, bring it here. And what are we going to do with it, Aiden Jutram? If I carry negative 2.5 to
You want to change it to positive.
No. Positive and minusing and plusing is not the operation going on here. Right?
You got to
What
move it to the left.
What is understood between negative 2.5 and this bracket? What is understood in between here? What operation?
Multiply.
What's the opposite of multiply?
Division.
Division.
So this will be negative 40 divided by negative 2.5, which is equal to, I could drop the brackets now, right? It'll be x squared minus 60. Negative 40 divided by negative 2.5 is what? Anybody?
16 flat.
So it's positive 16.
Positive 16 flat, right?
Yeah.
Is equal to x2 minus 60. When I carry minus 60 here, what do I do to it?
Yeah,
Addition.
So it'll be 16 plus 60, all on top of that by is x2. What is x2?
X2 is 76.
Right. 76 is equal to x2. Now tell me if it making sense now. Right? So they don't have 76 here on this graph. Right? But it's like if 76 was somewhere out here, 76 will be where? Like somewhere, it'll be somewhere like here. 76. And it's like your graph coming down. You'll have to follow it. It's like a graph coming down. I'm going to put this in a different color. I'll put in green. So your graph is going to decelerate green. Right. So we're coming from here and we're going straight down to here. Everybody good there? So where 76 is. Cool?
Yes.
Now, what did the question ask? The question asked me, how long did it take for the car to come to rest? So remember, we was at peak speed up here. So from here, let me see who following. From here to here, how long is that going to be? From here to 76. How much seconds did it take before that car come to zero? A speed of 0.
16 seconds.
16 seconds. Very good. Who said 16 seconds?
So I did.
Very good. 16 seconds, right? Everybody good there?
Yes, sir.
Right. So I'm going back down. Very good. Very good. So therefore, what is a vehicle?
I think so.
It's a car.
Yes.
Therefore, the car took, right? It will be 76 minus 60, which is 16 seconds to come to rest, right? Rest meaning
0.
Speed is equal to 0, right? 0 meters per second. I'm gonna put that there. 0 meters, and I'll fix this 7. 0 meters per second. Right? That was a real nice question. Really nice question. Right, guys?